Pre-calculus, Unit 2, Day 28 notes, Part 3, Page 3. Now we're given different functions, equations, and we want to find composition of functions. Okay, so the first thing they're doing is looking for, again, you start with the inside, h of 4. So h of 4 equals 3 halves times 4 minus 2. 3 times 4 is 12, divided by 2 is 6. 6 minus 2 is 4. Now we have to go and find g of 4. Go into g of x, 1 minus 2 times x, which we put in a 4, and we get 1 minus 8, which is negative 7. So just like we were doing graphically and numerically from a data table, except now we have the function. So why don't you guys try the next two and then check out what we have. Okay, so in the second one, we find f of negative 2 is negative 15. Just remember it's negative 2 squared, which is 4, and then the negative sign out in front of it makes it negative 4. So if you made a mistake there, that's probably where that was. We find p of 2 is negative 4, and then you just combine the negative 15 with negative 4 and get negative 19. Find g of negative 1 equals 3. Substitute that 3 in. So we get p of 3 equals 5 over 0. We cannot divide by 0, so that's undefined. Okay, the next part wants us to use equations to find these algebraic compositions. So again, start from the inside. So we want to find g of negative 2. And again, they give us f of x and g of x. And all three of these tasks are kind of related, with task 3 putting together task 1 and task 2. So when I want to find g of negative 2, every place I see an x, I'm going to substitute in negative 2. Negative 4 plus 1 is going to be equal to negative 3. Now let's go in and we're going to find f of negative 3. And we get 2 times negative 3 squared minus 3 times negative 3 plus 2. Negative 3 squared is positive 9. 2 times 9 is 18 plus 9 plus 2. And we get 29, excuse me. So we just found that f of g of negative 2 is positive 29. We'll come back to that in task 3. Okay, now in task 2, they want us to just find f of g of x. So they don't want us to put any numbers in, but now every time in f of x, every place we see an x, we're going to put in g of x. So it's 2 times x squared minus 3 times x plus 2. And now every time we see an x in the original function, we're going to put in g of x, which is 2x plus 1. So now I have to go and I have to do a little algebra. So we're going to expand this. So we're going to square 2x plus 1, and 2x plus 1 times 2x plus 1 is going to be 4x squared plus 4x plus 1. Then we're going to distribute this negative 3, negative 6x minus 3. Just make sure you distribute it to both values, and it is negative 3. And then bring down the positive 2. Let's distribute the 2 here, and we should get 8x squared plus 8x plus 2. So that is distributing this 2 to each and every term. We still have minus 2x, excuse me, minus 6x minus 3 plus 2. And now at the very end, for our f of g of x, when I combine like terms, there's no other 8x, there's no other x squareds, excuse me. 8x squared, 8x minus 6x is 2x. Then we have 2 minus 3 is negative 1, plus 2 is positive 1. So this is what we get for f of g of x. Now task 3 asks us, hey, let's put it all together. Let's use the equation we just found. So we just said f of g of x was 8x squared plus 2x plus 1. Now let's put in f of g of negative 2. So let's put in negative 2 here. And let me just write these down. So we know that f of g of x equals 8x squared plus 2x plus 1. And now we are going to find f of g of negative 2. Now I should get the same answer when I did them each separately. I found g of negative 2 and put that into f of x. I got 29, so I should get the same answer, but let's check it. 8x squared plus 2x plus 1. Every place I see an x, we're going to substitute in negative 2. And negative 2 squared is positive 4. 2 times negative 2 is negative 4. So I get 32 minus 4 is 28, plus 1 is 29. And that's exactly what I got on task number 1. So that shows that, hey, if you do the composition first of functions and then substitute in the value, that's the same thing as if I treated them as two different functions and substituted to the inside function first and then got that value and then substituted that into the outside function. So it doesn't matter which direction you do it, it's still going to be the same. Okay, so that's the end of part 3, and I'll put a part 4 to finish the last page of the notes.